when we are analyzing using structural equation model, um, we only we don't only focus on direct effect of a certain variable to another variable, but it can also measure the indirect effect. So in a structural equation model, the one that is introduced to you is path analysis, which is also a form of structural equation modeling, um, but without the structures. So to analyze the data, we have to import it to the software or the program from a selected database. So our database is, so we get the data using this icon. This is the icon, select data file. You just have to click that one, then click the file name. You find the location of the file. I think the data name is TPB. So you can click Excel point 8.0 if the data is from Excel. If the data is come from SPSS, then you can use this PASW statistics.sub. This is if your data is coming from SPSS. But since our data is coming from Excel, then you have to click that Excel 8.0 and you can find the data. So you click that one, then click open. So you will know that the data is already being imported to the Amos. You can see the values here, the n, which is the sample size, 100 cases. So that would mean that the data will now enter the Amos software. So after looking at whether the data is already in, based on this particular group name, file, and the number of cases, you will click OK. So after which, remember that in a certain um, analysis, particularly in structural equation modeling, you have to ensure that your model's relationship is coming from literature or theory. So, based on the model that has been presented, you are utilizing the theory of planned behavior. Okay, so I listened to the seminar the last time. So it was anchored on the theory of planned behavior. So according to the theory of planned behavior, a certain behavior can occur. Okay, if a person, okay, so has an intention to perform the behavior. Okay, so before a behavior can occur, the person must have an intention. So for example, the behavior is turnover. Okay, meaning turnover behavior, meaning you are leaving the organization. That's the behavior. But before you will leave the organization, you should have an intention. So the stronger the intention, according to the theory, the stronger the intention, the more likely that the behavior will occur. Okay, so so that would mean that there are two variables in the first two statements of the theory: the intention and the behavior. So we can create a box. So you can duplicate that one. There is an icon here, duplicate objects. You can click that duplicate objects. Okay? So dalawa na siya. So according to the theory that, so you have to place an arrow based on what the theory is all about. Okay? So before the behavior can occur, a person must have an intention. So you click this icon, select one object at a time. You can double click this so that you can place a variable label. So the variable label here, turnover. Okay. Then before a behavior can occur, then there should be an intention. Okay? So this is turnover intention. Yan. So you can see that this is what the two statements of the theory would like to illustrate. So there is another additional statements in the theory, and it says that intention is in turn influenced by three factors. Okay? So sinabi ng theory of planned behavior, we can duplicate the object. It is influenced by three factors. Sinabi nila that these particular factors involve attitude. Okay? So you can right click then object properties. Intention is in turn influenced by three factors. The attitude towards the behavior. So you can have positive or negative attitude towards leaving the organization. And then the next is subjective norm. So subjective norm is a social pressure. So when we talk about social pressure, if your co-employees are already leaving the organization, then most likely you will have an intention also to leave the organization because that is what you have observed among your co-employees. So this is social pressure, this subjective norm. And the last is the perceived behavioral control. So in the perceived behavioral control, um, it says the ability of the person to perform the behavior, meaning um, can you leave your organization if you think that it could be an economic loss to you and to your family. So you have to decide on that particular aspect. But if you can leave because you have a lot of savings, then most likely it could lead to intention to leave, or it can even go to a direct leaving the organization or direct turnover behavior. Because according to that theory, that it is the perceived behavioral control could have a direct effect on the turnover, uh, can have a direct effect on the behavior. So with that, we can provide an arrow based on what the theory is all about. Okay, that these three factors can have a what we call as an effect on the turnover intention, and perceived behavioral control could have a possible direct effect on the turnover behavior. So we can already see right now a path. Okay, so this is path analysis in which the path is represented by arrow. The turnover intention has a direct effect on turnover, including the perceived behavioral control, which has which could have a direct effect on the turnover or the actual turnover. And these three factors, attitude, subjective norm, and perceived behavioral control, may also have a direct effect on the turnover intention. That's based on the theory, but we have to test that one. So in Amos software, once there is an arrow, single-headed arrow from an independent variable pointing to another variable, you need to have to place an error variable. So you can click this icon, add a unique variable to an existing variable. This represents an error variable. Just click the box and just click the box because this turnover, there are two arrows pointing it. So meaning we have to place this error variable. So you can click plugins, then name an observed variable. So unobserved variable, this circle. So you just have to, these are error variables. You have to click that one. So this is E1 or E2. So it will just automatically name the variable. Then after which, you can already set the analysis. You click view, then analysis properties. Then you click standardized estimates, squared multiple correlation. Okay, so you can click close. Then click analyze, calculate estimates. Five variables are not named. Okay, now in this particular case, we have placed only the label, uh, variable label, subjective norm. So these are the five variables that we don't name. So the name of that variable, the variable name, should be coming from the data that we have. So in order to get the data, you just have to click this list variables in the data sets. Click that one. You can see now the data. Okay. So this is the data. Again, I'll close it. I'll click this. Okay. Then I can see now the data. You can just drag. It may change the variable label. I don't know, but it may change. Okay. So you just drag that one, attitude. Okay. I think it changed. Okay. Then subjective norm. Then perceived behavioral control. Then intention. And then behavior. Okay. So, but you don't have to worry if you can, if it has changed, then you can just double click it. You can just type again the in the variable label attitude. You have the subjective norm. Okay, and we have the perceived behavioral control. Okay, and then we have the intention, or the turnover intention, and then behavior. Okay. Click close. I hope that this will run. Click analyze, then calculate estimates. It will um, suggest correlation of the different boxes or observe variables or variables, but you can proceed to analysis. You need to type the file name. So this is sample Amos. Then click save, and then it can have the analysis run. You can see here there are two rectangular shape. We have the first, the view, the input, and this is second is the output. Input, doon natin uh, gina modify ang model. We created the model in the input view, but when we click the output view, it will now give you the values. These are path analysis. These are multiple sets of regression analysis. Okay, we can click the unstandardized estimates. We can click the standardized estimates. These are regression beta values. Okay, so you can see that the beta value, we know already that in regression analysis we have beta values that we will be interpreting, and that beta value would mean that for every unit increase in the attitude, there is a corresponding increase in the turnover intention by 0.54. So meaning when attitude is increased by one standard deviation, the turnover intention will increase by 0.54. In the same way, subjective norm, because the beta value is also positive, for every unit increase in subjective norm, there is a corresponding increase in the turnover intention by 0.27. And perceived behavioral control, for when perceived behavioral control is increased by 1, the turnover intention is increased by 0.42. And at the same time, this turnover intention has a direct effect on behavior with a beta value of 0.27. So again, the same interpretation in the regression analysis, that when turnover intention is increased by one standard deviation, the behavior will increase by 0.27, and as well as the perceived behavioral control, because there is an arrow that for every unit increase in the perceived behavioral control, there is a corresponding increase in the behavior by 0.56. So these are beta values. So to determine whether the beta value is significant, you can click view, then text output. So after you click the text output, um, I'll go to the text output window. Amos Output. Okay. So after you click that one, you can go to estimates. Okay. And this asterisk will represent 0.000. Okay. So that is meant by three asterisks. But when it will reach above 0.000, then it will be it will represent now the figure and the number. But when you see three asterisks, that would mean that it's 0.000. The p-value is like that, and of course it's less than 0.05, so that is significant. So you can see at the side, in the side portion, you can see attitude, arrow, intention. So attitude and intention, the beta standardized regression nasa baba is 0.543, 0.54, and the p-value is 0.00. So meaning that's significant. As well as subjective norm and perceived behavioral control, the p-value is also significant with a value of 0.00. So meaning all of the relationships are significant. Okay, it's less than 0.05. So that would mean that they have a direct effect on the variable that they are predicting. In fact, in the Amos, it will actually give you as a statistical interpretation. Just have to click. Okay. So when you click this one, okay, here's the interpretation. When attitude goes up by one standard deviation, intention goes up by 0.54 standard deviation. So it will give you statistical interpretation. Just have to click that one, including the p-value. If you click that one, the probability of getting critical ratio as large as 7 points. So they are actually computing the this is actually the specific way on interpreting statistics. But in us, we just have to say that it's less than 0.001. But our what we call as our test, the level of test natin is 0.05. So in other words, the regression weight for attitude in the prediction of intention, kasi you can see that is significantly different from 0 at 0.01 level. So it actually compared to 0. That's the concept of probability value. So meaning that is significant. Okay. But in your interpretation, you can just copy this one and that's already analysis. But you can just make it more practical and understandable. So you can say that attitude significantly predict intention with a p-value that is less than 0.05 and a beta value of 0.543, a standardized beta. So this means that when attitude is increased by 1 standard deviation, the intention will have an increase of 0.54. Okay, so that's the way to interpret this series of multiple regression analysis. So let's go back to the that's one thing that you have to interpret when you are doing the path analysis. And then let's go back to the model. Okay, so in the model you can see another value. Okay, the value in the model, you can see here this 0.54. Okay, so you can see the 0.54 above the turnover intention. What is meant by that? Okay, so what's the meaning of that 0.54? I'll try to migrate all of this. Oh, sorry. Mm-hmm. Yan. So that we can see. Then, okay. So above the turnover intention, you can see the value 0.54. And above the burn behavior, we have the value 0.51. So what is that? So that is what we call as the squared multiple correlation. So the way to interpret the squared multiple correlation is just the same as the way we interpret the R squared. You remember the R squared in multiple regression? So this is the amount of variance that can be explained by the different factors that predict a certain outcome. So you can see the factors or the variables that are predicting turnover intention, tatlo. You can see the three arrows here, the perceived behavioral control, subjective norm, and the attitude, pointing to turnover intention. So how much variance that these particular three variables explain turnover intention? So you can see that the squared multiple correlation is 0.54. That would mean that 54% of the variance, okay, of the turnover intention is explained by the three factors: attitude, okay, subjective norm, and perceived behavioral control. So just like the R squared, we can also say that the it would also mean that 46% of the variance of turnover intention, okay, can be attributed to other factors other than attitude, subjective norm, and perceived behavioral control. Okay? So these are the three factors that are part in the model. So these three factors explain 54% of the variance of turnover intent. That's somewhat huge. Okay, so that's somewhat big. Okay, for a three factor. So meaning there could be another factor to make it 100%, but that's not part of the model. That can be for the future study. And then in the behavior, there are two variables pointing it, turnover and perceived behavioral control. So how much variance do this turnover intention and perceived behavioral control predict the behavior, which is 0.51? So it explains 51% of the variance of behavior. These two variables explains 51% of the variance. So that would mean that 49% of the behavior can be attributed to other factors aside from turnover intention and perceived behavioral control. So to look at these values in the text output, you just click view, then text output. So let's go to text output. Let's look at the squared multiple correlations. Okay, it's the Amos output. Right, so this is the estimates. We go down, it's in the bottom part, the squared multiple correlations. Okay, so the value for the intention, it is explained by three factors: subjective norm, attitude, and perceived behavior. They explain 54% of the variance of intention. So to determine the interpretation, just have to click that one. Okay, it is estimated. So you can see that it will give you the statistical interpretation. Yeah. Can you see it in the screen? The statistical. Can you see?
Yes, sir.
Okay.
Yes,
So
sir.
I'll read this. It is estimated that the predictors of intention explain 54% of its variance. In other words, the error variance of intentions is approximately 46% of the invariance of, so meaning this is purely statistical, but it will just say that this error variance, meaning these are factors that cannot be found in the model, which can be this 46% can be attributed to some other factors not present in the model, but we can actually have that one as another study. So you can see that's the goodness of this Amos. It will give you statistical interpretation. So let's go back again to the model. So what's the next step in structural equation modeling? The next step that you have to do is to determine the goodness of fit of the model. Okay, whether the model is a good fitting model, then of course you have to determine, you have to test the fit of the model. So in order to test the goodness of fit of the model, you need to look at the output, the text output. There is a portion here, view text output. Then let's go back again to the text output. Um, Stop presenting, window Amos output. Then you can see now the text output. There is a portion here, model fit. You click the model fit, you can see a lot of indices. Okay, What's the most important index? We have the chi-square goodness of fit. The p-value must be above 0.05, but based on the model, it's 0.000. That's less than 0.05, meaning based on that, it does not pass the criteria of fit for the chi-square goodness of fit. The p-value should be above 0.05. So it failed, okay? The Cmin DF should be less than 3. But our Cmin DF is 34. So that is way above 3. So it does not fit based on the criteria of the Cmin, which is the chi-square goodness of fit. Now, we can also look at the one that I have um, selected. These are the common tests of fit that has been reported in every research journal utilizing SEM. So we have the GFI. It should be above 0.90. In some literature, it can be above 0.95. But our result is zero point 0.6. It's less than zero point 0.9. So it is not fit using the GFI. GFI means goodness of fit index. So it does not fit using the GFI index. The NFI index, NFI means the norm fit index. It should be above zero point 0.9. It is now, the result is zero point 0.5, so it's not fit. The TLI should also be above zero point 0.9. The result is zero point 0.1. It's not fit. CFI, it's 0.55. It's not fit. It should be above 0.9. CFI is comparative fit index. TLI is Tucker-Lewis index. So these are the most common indices that has been reported for SEM. Another is the RMSEA should be less than 0.08. It's above 0.08, so it's not fit. The P close is should be above 0.05. The result is 0.000. It's less than 0.05, so it's not fit. So all of the criteria indices that I have presented, okay, the indices, the results does not fit the criteria of a goodness of fit. So that would mean that although we found that there is a significant relationship between the variables in the model, then when it comes to model fit, it's problematic. So in SEM, there is what we called as a portion of the process, which is model modification. So in a model modification, you need to specify the model to attain the fit, but it should be supported by certain literatures. So you don't need to uh, remove the arrows or remove the variables or without any supporting literatures or provide certain relationship pattern without any support literature. So for example, you go back to the input view, I have found a literature to support that these three variables are most likely correlated with each other. Okay, and then yan. Okay, so let's see if we will correlate this one. I found the literature and let's see if that will improve the model fit. So I click analyze, then calculate estimates, same pa rin. And you can now see the correlation results. These are R value, okay? You know already the Pearson R correlation, right? So that is why this is the R value, the Pearson correlation coefficient. This is the strength of the relationship. And let's look at whether there is an improvement in the model fit statistics. So I will look at the Amos results again for the model fit statistics. And let's see if there's improvement if we correlate certain variables. So you can see still the chi-square p-value is less than 0.05. The Simin DF improved, but it's still above 3. A while ago, it's about 30, but now it reduced to 14. Okay, and then but still it does not fit the criteria for the Simin for the chi-square. So goodness of fit, so it still does not fit. The GFI improved. It's now above 0.90. Okay, so more likely that it is fit, the NFI, the norm fit index, improved to 0.92. You can see it's all of these are less than zero point 0.9, but now it is already increasing. TLI does not, still less than 0.90. CFI, it's 0.93. That's okay. And then RMSEA is still above 0.08. Peak close is still problematic. So in other words, there are only how many parameters that we include? One, two, three, four, five, six, seven, eight. So among the eight indices, only the following pass: NFI, CFI, and GFI tatlo. So meaning we still cannot assert, because it's 3 out of 8, we still cannot assert that this particular model is a good fitting model to explain um, turnover behavior. So with that, we can look for another literature to support whether we can still specify the model. So let's look at the model again. And for example, you have found a literature to support that. We go to input interface, that attitude has a direct effect in behavior. So you found a literature on that, that a good attitude or bad attitude, any attitude, that an attitude variable may likely predict behavior. So you found such literature, you place an arrow, that's another re-specification of the model. It is now modified based on the theory of planned behavior, but the variables are still available. Okay, there's no removal of the variables. So let's analyze it again, calculate estimates. So you can see now improvement, and let's see if there are certain improvement in the goodness of fit of the model. So to determine that one, let's look at the output. Okay, Windows. Okay, Amos output. So in the Amos output, let's click the model fit. All right. So look at the developments when we do rest specification. But again, when you rest specify the model, you need to have a literature, a theory to support relationships. Now you can see that the p-value is now above 0.05. This is already fit. The CMIN DF is 2.60. It's less than 3. It already passed the criteria for the CMIN DF. So this is already okay. Okay. And then GFI is 0.99. Much better. Okay. It's almost 1. Almost perfect fit. The goodness of fit index, it's 0.99. That's fit. NFI is already 0.99. It's already fit. TLI 0.95. It's great. CFI 0.99. So all of these particular indices already, the values already pass the criteria based on the selected model fit indices. RMSEA is still a problem, but the peak close is, it's still above 0.08, but peak close is already above 0.05. It's fit for the peak close. So among the 8 parameters, there is only one that does not fit the RMSEA. So you can just report that one, but as in the many parameters that you have included, so you can say that this is the good fitting model. Okay, that this is now the good fitting model to explain turnover behavior of employees, because majority of the indices are already, or the results are already passing the criteria of the goodness of fit based on each specific indices. So that's how to assess, and this is now a modified model of the theory of planned behavior, and this will now fit to the participants that you are studying. So that is why theory is always tested across time, and you can now already say that there is now a modification in the theory, and this is now, that particular modification is based on your study. Okay? And you are now contributing to the literature, because this is something extension of the theory of learned behavior. You can say that attitude already have a direct effect on the behavior. So there is now uniqueness of your study, the novelty of your study, and this is actually a good outcome and actually a good model to predict turnover behavior of employees. So that's how to analyze using path analysis and testing the goodness of fit using the Amos software. So I will now entertain questions. Any question? So